So time to put you to the test a little bit. Now this is a general map of the world. So we have some pressure systems here. Of course, our lows are what we call cyclones, and our H's are anticyclones. So you see these isobars, for instance, kind of from left to right. If we pick on this guy over here, the Pacific High, and I see 120 isobars, 120 millibars, 117 millibars, stepping down 3 millibars from a high pressure. Okay, so now that semi-permanent high was created what? By the descending air about 30 degrees. See how that works? Okay, we have another semi-permanent high here, semi-permanent high here. So that's one of the things I want to point out. The other thing I want to point out is what direction is the wind moving. So the wind actually is, what color pen do I want to go? Around a high, that's what an anticyclone, so we're going to look for clockwise motion, clockwise around a high. And I'm thinking it is following what we think it should. Okay, so this is like a pressure map. Those anticyclones, the semi-permanent highs, are created because of the descending air between what? The ferrule and the polar cell. So let's pick on some low pressures here associated with the ITZ stands for Intertropical Convergence Zone. So if we pick on, for instance, this low pressure here, well, that's not a good example. Let's pick on this low pressure up here. The low pressure would be, oh, did I say that wrong? Darn it. These low pressures would be where the, no, I think I said that right, where the ferrule and the polar cell are having air rise. So we have an Aleutian low, an Icelandic low. Okay, that might be about it. Now we can kind of convince ourselves that they're low pressures. They are indeed cyclones if we look at the isobars. So here I have 1002, 1005, 1008, 1011. Looks like they're stepping up 3 millibars per isobar. So yeah, that all works. So around these semi-permanent lows, we would expect wind to go what? Counterclockwise. And let's see if they are. Let me grab a red, I guess. Counterclockwise. Counterclockwise. Yeah, I think so. Okay. So there you go. That's kind of, and a minute actually, I'll give you a precursor. When it comes to the movement of ocean currents, they are driven directly by wind currents, and these are wind currents. So that was January, and this is July. Now, right away, and actually we're going to talk about this in a minute, right away, if you see the Intertropical Convergence Zone, it's a purple line, notice that it migrated north in July. Not so surprising, is it? Okay. For instance, it was clear down here in South America in January, and it's right up here in South America in July. Here in a minute, we're going to actually focus on this neck of the woods. Okay, this is India. Okay, so notice the Intertropical Convergence Zone is clear down here, and then actually 6 months later, it's clear up here. So the Intertropical Convergence Zone really migrated. The one last thing I also want to mention is we said that deflection is to the right in the northern hemisphere, and deflection is actually to the left in the southern hemisphere. So I don't want to mess you up, I really don't. But around highs in the northern hemisphere, we said that wind will go clockwise. Around highs in the southern hemisphere, wind will go counterclockwise. So let's just go give that a quick check. So here we have our semi-permanent high pressure associated with where the Hadley and the ferrule bump up together. And so, yeah, notice that this actually is going counterclockwise, but it's in the southern hemisphere. So I just kind of mentioned that. So let's take a look at that wandering intertropical convergence zone. Now, by definition, you've heard of monsoons, and actually North America has a monsoon also. All a monsoon means is that you have a seasonal swing in your precipitation due to moving circulation patterns. So the example I have here is the real popular one, the monsoon seasons that India experiences. So a little bit ago, if we kind of go back to the previous slide, I showed you back in January, here's where the intertropical convergence zone is relative to India in the Himalayan mountains. Okay, now actually in the winter then, India experiences dryness. This talks about orographic lifting that actually mirrors your mountains, and so we have the Himalayans doing some lifting and basically dumping any precipitation they might have on the other side of the mountains away from India. So in the summertime then, the intertropical convergence zone moves. Okay, so now instead of being down here, the intertropical convergence zone is way up here. Okay, that then moves the wind patterns, and so now we actually have that southeasterly trade wind actually coming up and bringing moist air, okay, slamming it up against the mountains, and we have orographic lifting, so it lifts up and it dumps on India. So it has an exaggeration with regard to precipitation between the winter and summer months. That is the definition of a monsoon if it's brought in related to these global wind patterns. So that's the Indian monsoon.